Hi everyone, welcome to my channel. This is TG Tips and I do educational videos and maths tutorials. Today will be part 1 on a tutorial on indices, so give it a thumbs up if you find it helpful and subscribe if you'd like to see more content like this. Share this with someone who you know needs help. Let's go! So first we'll start off by defining what are indices. Indices is another word for powers. So when you hear the term something to the power of something else, this is what it means. So here we have 2 to the power of 3, for example. That basically means 2 times 2 times 2, 2 times by itself 3 times. And there's some terminology that you just need to know. Using the 2 to the power of 3 as an example, in index notation, we would say that 2 is the base, and the 3 would be called the power, or the index. Just say power, it's fine. So just to get some practice at using the notation, we'll use 7 times 7 times 7 times 7 as an example. So in order to write this in index notation, we would first start by writing the base. So the base in this case is 7, because the number that we're multiplying by itself is 7. And the power we would find by counting how many times we are multiplying the 7 by itself. So we have 1, 2, 3, 4. So it would be 7 to the power of 4. And that is index notation in its simplest form. Now we'll go through the rules of index notation. We'll start off with the basic rules. The first rule is a to the power of n times a to the power of m equals a to the power of n plus m. So a stands for any number. So let's take 2 as an example. If we have 2 to the power of 3 times 2 to the power of 4, we would simply add the powers. So the base would stay the same, so we would have 2, and 3 plus 4 is 7, so it would be 2 to the power of 7. Nice and simple. And the same rule applies for division. A to the power of n divided by a to the power of m equals a to the power of n minus m. So if we divide, we just take away the powers. So using the same example, we will do 2 to the power of 7 divided by 2 to the power of 4. We will simply take away the powers. So the base would stay the same, it would be 2. And then 7 take away 4 is 3, so it would be 2 to the power of 3. And the third rule, it looks harder than it is, but it's a raised to the power of m, all raised to the power of n gives you a to the power of m times n. You'll usually see this written like this, so it's 2 to the power of 3, all raised to the power of 4, for example. In this case, we would simply keep the base the same, so it would be 2. And we would multiply the powers, so it would be 3 times 4, which is 12. So these are the rules to keep in mind. This is something that you're just expected to know. Anything to the power of 0 is 1, and written in as an expression, it's a to the power of 0 equals 1. I have 3 examples here for you, and I'll keep the rules on the right-hand side. One thing to remember, treat the coefficients as normal. So for example, here we have 12c to the power of 6 divided by 4c to the power of 3. We know from the rules of indices that we take away the powers, but for the coefficients, which would be the 12 and the 4, we would still have to divide them as normal. And the same applies for these. So with the brackets, it's everything inside of the bracket squared. So if we're squaring 12, we still have to take the square of 12. You can pause the screen and have a go by yourself, and I'll run through the answers on the next slides. If you don't feel confident with it, don't worry, we'll go through it together now. We'll start with the first one. So the first one is simplify 12c to the power of 6 divided by 4c to the power of 3. Referring to the rules here, we are using the second rule, which is here. As advised from before, we'll start off by dealing with the coefficients. So let's say the c to the power of 6 and the c to the power of 3 weren't there. We would usually just do 12 divided by 4. So 12 divided by 4 is 3. So we've dealt with the coefficient. And now we need to deal with the powers. The base would stay the same, so that would be c. And as we know from the rule, if we're dividing, we just take away. So we would do 6 take away 3, which would give us 3. So that would be this expression in its simplest form. That's 3c cubed. Let's move on to the next one. So the next one says, simplify 12y to the power of 8 all to the power of 2. So this is basically asking you to put everything inside of the bracket to the power of 2. In order to do this, like I said before, we still need to square the 12 as normal. So 12 squared, you shouldn't really need a calculator for this. You are expected to know your square numbers up to 12. So 12 squared, 144. And if we refer back to the rules, we are using the third rule here. So the third rule says a to the power of m all raised to the power of n gives you a to the power of m times n. So for this, we'd keep the base the same, so it's still y, and we are multiplying the 8 and the 2 together. So that would be 144y to the power of 16. So again, what we've done is we've treated the coefficient as normal, so we've squared the 12 as normal, and we've multiplied the powers together. So I know some people may have been tempted to do 24y to the power of 16, but it's not the same thing because the indice means to square. So if you square something, you multiply it by itself. We'd multiply the 12 by itself to get 144. But if we're squaring an existing power, we multiply the powers together, which is why we didn't square the 8. And the third one, the important thing with this one is to make sure that we don't mix the x's and the y's. We can only add together the power of x's and we can only add together the power of y's. Let's look at the rules again. So if we're multiplying powers, we add them together, which is the first rule here. We'll start by dealing with the coefficients. 7 times 3 gives us 21. If we're going to add the powers together, we'll start with the x's. X to the power of 3 multiplied by x to the power of 4. We would add the powers together, so the base would stay the same, it would still be x. 3 plus 4 gives us 7, so it's 21x to the power of 7, but we still need to deal with the y. So the y would stay the same, and we need to add the powers of y together. So y squared multiplied by y squared gives us y to the power of 4. Sorry, I probably should have chose a different letter than x because it just looks like a whole bunch of x's. Let's recap. We've multiplied the 7 and the 3 to get 21, and then we've dealt with the x's, so we've done x cubed multiplied by x to the power of 4, which gave us x to the power of 7, and we've done the same for the y, which gave us y to the power of 4. Hopefully that all made sense to you. I'll just do a quick summary of the things that we've gone through. One thing to remember is the general rules, which is the list here. It's just to remember the rules of multiplication, division, and raising to a power, and also a to the power of 0. We didn't need it this time, but just for future reference. Another thing to remember is to deal with the coefficients separately. So if we are multiplying something with a coefficient, we still need to multiply the coefficient separately. The same goes for division and raising to a power. So if we're raising a bracket to a power, we still need to raise the coefficient to a power. And the third thing to remember is to make sure you only apply the rules to indices with the same bases. So what this means is that we couldn't do c to the power of 3 times b to the power of 4 and just add them together. We would only be able to add them together if they both have the same base. Hopefully you found that useful. I just have some extra resources for you to use. So in the description box, I have left a link to a Google Docs folder where you'll find some activities for indices. The first one for the basics is a true and false activity, so it's really quick and it has the answers there for you. So if you do want to get some extra practice, you can use that. And also there's a link to a MathsGenie paper which just gives you some exam practice of indice questions. It is at Excel, but it's the same for most exam boards, so it's worth having a look at. But yeah, I hope you found the video helpful. Let me know if you have any questions. Feel free to email me on the email address at the bottom. But other than that, thank you for watching and I'll see you in the next video. Bye!